Hello, welcome, and a very nice Christmas evening or something, I guess. We are here for the Let's Code MS-DOS Christmas episode, and as in the last years, we will be using PowerBasic, the basic compiler by, well, good question. I had used the version by the German company Kirschbaum, but I think the authors were US based, and I think the version that we're now using here is maybe the US version. No, I think the version 3.2 that I'm using today is from the German company, but either way, it's a compiler for BASIC, not an interpreter, that compiles to DOS exe files. There are still versions of that floating around compiling for Windows, so some part of the company is still existing. I think the original author has died in the meantime, so may he rest in peace. But I used this programming language a lot when I was a kid because it was quite cheap to get. At first I had a slightly less legal copy, but then I got a booklet with the disc for, I think, 69 Deutschmarks or something. That was something that I could have saved up to from my pocket money. And then I had my first legal commercial copy of a programming language, and I could produce exe files, which was important to me, not to have a basic file that was like open source or anything. Later changed my mind and did a lot of open source development using GCC, etc. But that was way too complicated back then, so PowerBasic it was. But first of all, we're going to run Deluxe Paint because I actually took a picture of a Christmassy scene and converted it to PCX format because that's a very simple to load format and it supports 256 colors. Using ImageMagick on the Mac, but you could also use Linux, probably Windows as well, and it can convert a billion different formats. And I forced it to have 128 colors, obviously with a palette of 256 because I want to use the other 128 colors for some nice effect. And this is the image. I don't know who the author is, so I'm using this here for artistic and educational purposes only. Looks quite nice, I think, very kitschy Christmas scene. And our goal will be to render an animated fire here in the fireplace, stuck in here, using BASIC. And the palette has in the lower 128 entries the actual image colors, and up here I used our regular fire palette that we have used in so many episodes basically, and you can edit this very nicely with the palette editor here, doing all the gradients by using the spread button. And yeah, it will output a what is it called? It will output a chimney, I call it, PCX file, because coding a, let's say, a GIF file would be a bit hard. PCX uses a simple compression, which doesn't work very well on this image, because as you can see, it's 57 kilobytes, so it would normally be 64 kilobytes. So we saved roughly, let's say, 6,000 and a couple bytes. That's at least something. If the image were very smooth with not that much dithering, it might have been much smaller. I had a version before without dithering that compressed down to 40 kilobytes. Yeah, so PCX is not very optimal. It uses run length encoding, which means that it writes how many copies of a pixel will be done every time you have a pixel that is greater in value than 192, let's say 193 or 4. Basically, it will follow by a pixel number, let's say 128 or something, And this means that you have to write the pixel 128 two times, because 194 minus 192 gives you the number 2. And this can give you pretty good compression ratio. If you have like 250, it will be 68 pixels that are compressed into 2 bytes, for example. That's a pretty good compression ratio, but it's nowhere near as good as GIF, which uses the Lamp-Ziff algorithm or some kind of Huffman coding, and will give you much better compression on, especially on things like this very dithered image. But that's how it is. We will use this because it's relatively easy to code. And as I said, I will use PowerBasic 3.2 here. I also tried it with 3.5, but the IDE looks a bit more, well, it's black and white mostly. So I thought, let's take the classic blue and yellow look. The main program will look like this. First clear the screen, that's actually not really necessary. Randomized timer to get a different fire every time we start the program. Then there's a subroutine called Init graphics, which initializes the graphics mode. Load PCX, which loads the image directly into the VGA memory without any temporary buffer or anything. Init fire clears the chimney to prepare everything for the fire to actually work. Then we do a loop until there's a key press, which works like this: do loop until instead. And there is a online help here. As I said, this seems to be the German version, but you can also get the English version. And instead, for example, is the function that gives you the status of the keyboard, if there was a key press or not. So we can quit using that, and init text will go back to the text mode, obviously. And yeah, in the loop we will do a vertical blanking sync so that we are frame limited to 70 frames per second. Although this is still a compiled language, it's still so slow that it probably won't hit the 70 frames per second of a VGA card. And then after we're in the vertical blank, we will update the fire for minimal tearing effects. And I already created the subroutines here, more or less. And yeah, let's start off by learning how to set the screen mode, because usually you would write something like screen 13 in QBasic or QuickBasic, but PowerBasic never supported mode 13 for whatever reasons. I'm not quite sure, because it would actually be pretty easy to implement. So if we were to do that, it probably will complain, not like that. And let's run this. Illegal function call, exactly. So that's something that doesn't work. What we can do instead is, there is a statement called reg for register, and all the registers, or at least not the non-segment registers, are numbered. Register 1 is AX, and as we know, we can just load up AX with hexadecimal 0013, AH being the function number 0 and 13 the screen mode, and then we can call an interrupt, which works just by writing call interrupt with the interrupt number. And 10 hexadecimal is the graphics interrupt of the graphics card, and it will set screen mode 13, and there we are. We can copy all this down to the init text, and the text mode is 3 hexadecimal, so there we are. That's already that function. The vertical sync, we used that in the last Christmas episode, and I used inline assembly, and I thought, well, that's not even necessary. Might be not very optimal, but we can rewrite the assembly version. You can look it up in the old episode, just by pure basic. So we need 2 loops basically, so 2 labels, VSYNC 0 and VSYNC 1, depending on if the VSYNC is active or not. Here we're testing for active VSYNC, so we read from the register that shows us the status of the vertical retrace, which is hexadecimal 3DA, the VGA status port. And if the value has the bit 8 being set to 1 basically, so I can test for not equal 0, then we will loop, and the alternative is again reading. Once we are in the retrace, we wait for the screen to finish being drawn so that we end up again in the retrace, and we can actually copy that. And we wait for this to become 0. And of course we need to do it like this. And that's already our VSYNC input. So next up is the load PCX routine, which takes a file name as an input. And we'll code a very minimalistic PCX loader without too many checks. We will do some very rough checks that it is actually a PCX file and that it is run length encoded. But we won't check for the picture dimensions, so if you put anything in which is different from 320 by 200, it will produce some garbage. But yeah, you can enhance it if you want and make it more flexible. So first of all, let's open the file. It works with the open statement in BASIC, basically. So we open the file name for binary input as file number 1. And this is one big disadvantage, in my opinion, of BASIC, that you can read binary files only into strings, into string variables. So I do a get $ command here, and I will read 128 bytes into a variable called header. The idea being here that PCX files always have 128 bytes of header. That contains quite a bit of information. We will only check 2 different bytes. The first byte, which will be a hexadecimal or 10 decimal, signifying that it is a PCX file, and then the 4th byte containing a 1 if it is run length encoded. So, how can we look into the string? Most simply, I think, this is just for trying out how this works, by using a pointer and looking inside, because you can't index into the string very easily in BASIC. That's much easier in C, for example. So we take the segment to create a pointer of the header string variable, and we define a header pointer variable by using the string pointer function, which gives us a pointer to the string, only the offset, and the default segment will, for doing peeks and pokes, will be the segment of this variable. That's how pointers work in BASIC. A bit cumbersome, again. And then we can read out the value by using the peek function on this pointer. And if this is not equal to hexadecimal A, then we will basically just quit. I think we should do a init text and then print not a PCX file, and we'll print the number that we read instead, and then we'll end. Something like that, I would say. Then we need to skip forward to the 4th byte, so we increment the pointer twice to get to the 4th byte, and then we can basically do the same, like so. And instead of A, we use 1 as our comparison. So if it's 0, then we know that it's not run length encoded. and we'll print that as well, because that we can't decode. There are PCX files which just plainly dump all the bytes, basically, but we want to have something slightly compressed. So, and then we call devsec again, which returns to the normal data segment that BASIC currently uses. Second, we will read in the VGA palette that is in the file. The palette comes after all the picture data. It's the last 768 bytes. So what we'll do is we will again define a string variable. We can also do it like this. It doesn't have to have the $ here, but we'll use a local string variable. Then we will seek in file1 to length of file. This is a function that returns the size of the file of file number 1 minus 768 bytes. So this basically rewinds to the start of the palette in the file. And then we also read the string, get string from file 1, 768 bytes into the variable pal underscore. Again, creating a pointer. Devsec equals the string segment of the pal variable, and then our pal pointer will be string pointer of the pal underscore variable. And now we can set the palette, which we already know how to do from C. So we write to the port hexadecimal 63C8, which is the palette index register on the VGA card. And we say we want to start at color 0. And then we do a for I equals 0 to 767. Next I somewhere. And then we read out the color, which is done by using peek at the current palette entry, which is pal plus I, so the pointer. We could have also just incremented the pointer and used the while loop or something. But let's not do it like that. Then we have to make sure the PCX palette is actually stored from 0 to 255, but the VGA card can only handle up to 63, so we do a shift to the right of the color variable by 2 bits, which is similar to a division by 4, but doesn't lead to the exact same results I tested, probably due to the signed, unsigned nature or the floating point affinity of BASIC. I was not quite sure, but sometimes the colors were one off, and that was very weird. So I think the shifting is more accurate. And that we write to the data port for the palette, which is a 3C9 hexadecimal. And that's it. That should already set our palette. Next up would be decoding everything. And for that, we create a string called pix underscore with size 1, because we don't need more. There is an issue, we can't read all the data. I would have loved to just read in a whole bunch of data, but strings can only be something like 16 kilobytes at most. So we would need to use chunking, which might be more efficient because you don't have so many system calls for reading single bytes. But that makes the code much more complex and hard to read. So I decided to just read byte-wise, because we're not here for the performance, but during runtime you will see how slow this actually is by seeing how slowly the pixels end up on the screen. In C that would have been probably much faster. Perhaps I will rewrite the whole thing in C at some point, and we can do some benchmarking to see that. Either way, we need to keep track of our pixels. For that we need a long integer because it's bigger than 32,000 pixels. We start out at 0. Then we rewind the file to just after the header. So skipping the first 128 pixels, not pixels, bytes. And very important, I set the option binary base to 0 here, so the first byte in a binary file is byte 0. Otherwise you would have had to increment this number here by 1 to 129. But I find 0-based indexing much more intuitive. And then we do while count is smaller than 64,000, which is 320 by 200. Doing the loop. And we will read pixel by pixel basically, or byte by byte, from file 1 byte into the pixel variable, pixel underscore variable. And the actual value we can pick by just running the ASCII function, the ASC functions, on the pix string, which gives us just a byte value. And this is the value that we want to work on. Because the pix underscore is actually a string and we can't calculate with that. So we check if pixel is bigger or equal than 192, which means it is an hourly encoded pixel. If so, then we calculate the number of pixels that we have to draw, which is pix minus 192. And then we will read the actual pixel value, again from file 1 byte, into the pix underscore string, and the actual pixel value again is calculated using the ASC function. And then we can poke this directly into the screen memory, setting the default segment to be the start address of the VGA card, which is A000, and then we do a little while loop while numpix is bigger than 0, end of the while loop. Then we poke at offset count, because we are counting from 0 to 64,000, and that's exactly the linear address in VGA memory, the pixel in question. We increase the counter, obviously, once we did that, and we decrease the numpix variable. That's already the run length encoding. Only thing we need to do is we have to reset our default segment, and then we go off to the second part, which is a non-encoded pixel, which is actually pretty simple. We can more or less copy all this, taking most of this, poking the pixel, incrementing the counter, and resetting the segment. I think that should be it. Only thing left to do here is to close the file. And in theory, this should already compile, except that I did something wrong. DevSec, yeah, that's probably like this. Looking good. And there we go. You can see how slowly the file loads. We are roughly on the performance here of an 486 something. So that's really slow. Maybe a 386, I'm not sure. 10,000 cycles is somewhere there. Not super fast machine, but already a pretty performant machine that could, I think, run much faster than this. So that's probably basic for you. But the graphics loads fine. The RLE encoding works. You can use whatever graphics you choose. Now we just need to do the fire. And how do we do that? First of all, We need to initialize the backdrop, otherwise we will calculate on the pixels that are already there. Again, default segment should be the VGA card. We could probably get away with setting this only once. We do have one place like here where we use the string segment. So best practice is to always set the default segment just for the occasion and then reset it. It probably will compile down to a push of DS and restoring using devsec with a pop from the stack or something. So it's probably pretty efficient. So I usually keep it like that. So I measured a little bit the pixels using Deluxe Paint. You can use your picture editor of choice to figure out where to place the fire. And I noticed that it makes sense to go from Y coordinate 103 to 133 to get a nice rectangle in the chimney that works. And in the X direction I measured 140 to 195. That's just arbitrary and specific to this particular picture. And what we'll do here, we will poke into a VGA memory, and the conversion of the X and Y coordinates is always X coordinate plus Y coordinate times the width of the image, which is 320. And this gives us the offset into the VGA memory, and we're using color 128, which is the black in our color gradient, which is basically the cool, not fiery color. And the higher you get, up to 255, the hotter basically the fire gets. Yeah, that's that. That's already the initialization. You can already take a look. Oh, yeah, we forgot an equal sign here. And that should draw a nice black rectangle, right smack in the middle of the chimney. That's correct. And now we need to update the fire. Very similar, default segment equals hexadecimal A000 and resetting at the end. And now we will initialize the fire. We will put the fuel, so to speak, in there. And I figured out that to get a good effect, we go from 0 to 54, which is the width of the fire, so to speak. And the idea being here that if we're at the borders, which is the first and last 12 pixels, then we are not drawing any fuel. So I have two rows of fuels, which I call R1 and R2. So both will be set to the cold, basically. And otherwise we will randomize the amount of fuel that will be there. So R1 equals 128 times R&D times 127. R&D without any parameters will give us a number between 0 and 1, float number, and multiplied by 127 we get at most 255 summed together. And we can use the same here for R2. In PowerBasic 3.5, I think you can also give a range directly, something like 128,255, and it will give you this. But I think PowerBasic 3.2 doesn't have that yet, or at least the older versions don't. So this is a bit more compatible with older basics and easier to port if you want to do that. So next we need to poke that into memory. X coordinate was 144 plus the Y coordinate, and we're going for rows 132 and 133 because that gives a nicer thing, because we will use a bigger range to average the fire. So times 320 and plus I, which is the offset into the X direction, into the row, basically. And we use the first random variable and the same for one row below that with the second variable. If we do that, we are missing a 2 here, but that's it, and we should have the fuel being used. Oh, we got an overflow. What did we do wrong? Something. Let me quickly check. And going into debug mode here, which is very useful, you can add watch variables, which appear in the bottom part of the screen. You can see R2 is 10,000, which doesn't fit into a byte, obviously, which is due to the fact that I put an asterisk here where there should have been a plus. So this should be much better, and it actually gives us the fuel fizzling away, and we can use this to actually compute the fire, which is not that hard, and is the last part that we need to do. So after we have done that, we will iterate over the y direction from 104 to 131. That's 2 less because we will look up to 2 rows ahead, which gives a nicer, more chaotic fire than doing the thing that we did in a previous episode in C. I noticed that this here looks, in my opinion, a bit more natural and fire-like. And in the X direction we go 143 to 190, not to include the chimney colors themselves, because that will lead to very weird results. But you can play around with that. And we will create 2 more random variables from -1 to 1 to shift around the look ahead. This will be different from pixel to pixel and gives this more realistic thing. So here we are producing a value between 0 and 2. Adding that to the -1 will lead to values between -0 and 1, -0, 0 or 1. We're doing the same for the second random variable, so we get maximum randomization, and then we will compute the color. The first part of the color will be reading at the current x coordinate plus the first random variable to shift around in the x direction -1, and we will do something very similar. Basically what we'll do is we will have a shift by 0, by -1, by 0, and by +1. So we look to the left on the pixel and to the right, shifted by a random amount. And we will do the same for the y direction. We'll do y plus the second random variable +1 times 320 -128, because we need to subtract the shift in the pallet data, otherwise we will get also very weird results, and we can move that around. Here we will do the same, actually. No, that's correct. Here we will always look ahead 1 row to the bottom, but randomly shifted up or down even further. That should do the trick. Then we need to normalize this, because we will get a value which is much higher than what 1 byte can take. So we need to divide at least by 3, but I noticed that then the fire will be too big, and to get a bit more attenuation I divide by 3.4. You can tweak that, and it scales the height basically of the fire, how quickly it cools off basically. And the resulting value will just write to the x and y coordinate that we're currently looking at. And we have to re-add the color offset again. And that should actually be everything we need. So let's run the program. And this is actually much too small. I need to figure out if I forgot something. And yes, indeed, I forgot to add all this up together. I just copied and pasted. And of course, this was only one row of colors. So you have to add color to the previous value, and that gives us the whole sum over all the 3 pixels. And if we do it like that, we should have a nice growing fire, which also wobbles around relatively realistically. And I think this is a pretty nice effect. So there you have it, a cozy Christmas scene. Written in PowerBasic for MS-DOS. Link to the source code is in the video description. Feel free to check it out, play around with it. And with this, I wish you a very Merry Christmas, holidays, festivities, whatever you're celebrating or not celebrating. And I hope to see you next year on this channel. Share, like and subscribe, the usual stuff. Leave a comment. Tell me of your basic adventures. And yeah, I hope you are having a great time. And yeah, I'll leave this a bit running and see you in the next video. Bye.